So, with a career spanning 20 years, Dr. Vaibhav Bansal is specialized in cloud consulting and delivery, bringing a wealth of experience to enable and enhance the multi-cloud projects and IT consultancy practices. So, as a seasoned cloud consultant and delivery expert, Dr. Bansal have successfully led cross-functional teams through the planning, building, launching, and management phases of large-scale, high-scalable software products. His proficiency extends to agile Scrum methodologies, providing a strategic advantage in ensuring the seamless execution of projects. So since 2021, Dr. Bansal have been a valuable contributor to Evident, leveraging his technical acumen and leadership skills to drive success. So holding multi-cloud certificates, he possesses a comprehensive understanding of cloud technologies. His certification as Scrum Master underscore his commitment to agile methodologies. So he has the expertise in many domains, including project management, delivery management, agile projects, project planning, people management and team management, Jira management, and sprint review. So he had got many certifications, including the Certified Scrum Master, AWS Certified Solution Architect, Google Cloud Professional, Cloud Architecture, Cloud Associate, Cloud Engineer, Google Cloud Digital Leader, Azure is at 900, Azure Fundamental Certifications, DP 900, and Azure certifications. So today he will share the expert talk on the title Recurrent Neural Network Applications Time Series Analysis in the Cybersecurity. So, Dr. Vaibhav, now you can continue the session.
Okay, thank you, Dr. Pankaj, for giving the brief about myself. So, further, I would like to add, like I was and I am into IT. Before joining into the IT company, I started my career as a teacher only in one of the colleges that is located at Faridabad at that particular time, known as Lingias. Now it is a university, and from then I moved to the corporate, and till that I'm in the corporate right now. So when you terms in terms of the corporate, so I am actually working on the cloud platforms. Basically, when you say a cloud platforms, I'm working in the cross-functional platforms, and one of the projects that I'm right now doing it is something based on the uh, transformation on the cybersecurity platform. So I will discuss also that in this form. So in this forum, and so I'm just starting the presentation, so everyone can have a look, and then we can have a quick round of, you can say, discussion also. Okay, so I'm sharing the screen. So we are here for the recurrent neural network application. So I hope everyone, most of the people must be having some understanding about the neural networks. So can we have something, why we call a neural, what is a neural network and how it does the application? So do we have some information about it from the large participants of the participants? Can somebody let me know? Hello, I'm audible
Participants, you
to all?
can drop the response in the chat box. Although the communication is muted, so the response can be dropped in the chat box.
Okay. So,
Sir, a
okay, let's
model
start.
inspired
Could you
by the
please,
structure.
yeah, please again.
Sir, any model which is inspired by some biological neural networks like animal brains.
Okay. So the fundamental is there is absolutely correct. Any data model, any working model which is inspired by the neural applications or by the physics of a neural is known as a neural network. So when we say it's a neural network, it means there should be some connection between the the delta, and some the hidden particles and the output of the source. So this combines to a neural network application. And when we say a recurrent, it means anything and everything which which is not persistent, changing with the time, which it comes under the recurrent neural networks. Like if a person is walking, so when we start to a walking from one point to another point, there may be number of series that we are taking. It may be we can shake our head, we can shake our hands, the legs are moving, the body is actually into the motion, or body into the rest. So these all are the parts, small pieces of a series which comes to the part of a time series analysis in terms of a neural networks. So now let's start the outline what we have to present. So this is the what I am going to present. And okay, share my thoughts. Like, so the outline is very clear cut. I will share the sequence modeling, RNN. In terms of RNN, I will try to give you the update knowledge of anomaly detection, user behavior, predictive threat intelligence, log file analysis, phishing and the fraud detections, automated instances, what challenges still we have right now in this model, what is the basis and the foundations and essentials for the RNN, and right now in industry, what is in practice and what is in application of the use for this one. So let's start with the recurrent neural network. So RNN is a basically a class of, you can say, various neural networks designed to handle the sequential data. So when we say a sequential data, you can say the data has the horizontal fieldings, like every small piece, every small bit of information would be handled into the data format. So this is, and why this is done? This is done to get the actual time series analysis. So when we say actual time series analysis, we mean to say that the smallest event that is occurred in the smallest part of a time should get into the series, so we can analyze it better to get the better output from them. So now this is the in context of cyber security. So when we say a particular cyber security, so by the sequence pattern or by the sequence of a data, we can detect or we can predict what threat or what has been done to the security data, or it has not been done. So what we used to analyze, it is a network traffic, user behavior, system logs, and a time dependent. So when we say a time dependent, so time dependent gives us the sequence of the patterns on certain time. The load is high, the traffic is very high, the behavior of a different users are very critically different what they used to have, and system logs give us the detailed what went wrong, how got wrong, the users are exhibiting which feature, which logs they are doing it right now. The best example for time series analysis in the recurrent neural networks is a stock market prediction. So you might be knowing that there are a lot of softwares which do the algo trading, which is recently was banned by the SEBI also. So this actually predicts the time series, like what is the behavior on a particular instance of a time, like stocks are going on up and down, what is the ratio of it is going on, what chart it is getting prepared by this behavior. So this predicts the stock price prediction. So this is the best example that I could find for the neural network here for RNN network. So next move to the application. So now when we say now when we have a time series, and the time series is associated with the some kind of analysis. So the first part that comes to the time series in terms of a cyber security is a anomaly detection. So when we say anomaly detection, when we try to analyze the time series from the network traffic logs or identify the unusual patterns. So when we say unusual patterns, if for an example, we have a set pattern that users should traverse from point A to point B and covering with the point C. But now what we are analyzing in the network traffic, the user is not traversing to point B, it is straight away going to point A to point C. Now this kind of a deviation or a pattern, it is very unusual pattern for a end user to go from A to C, where we have a defined part to go from A, B to C. So this kind of unusual patterns and or deviations may be due to the, you can say, anomaly detection comes here into the picture, and it can be the, like some intrusions can be there, like denial of service should be there, or file attacks are there. So this is the pattern for anomaly detection. So when we say anomaly detection, it means something which is not on the right path of a traversing going somewhere down the line, which don't have the recent or the known configuration or known analysis for the certain path. Now going to the next part for the anomaly. Next is the intrusion detection system. So we have this in RNN also, but in case if you talk about in a broader sense, before we have an RNN networks, we have an intrusion detection system where somebody try to intrude into somewhere, so the alarm goes on, the pattern sequence goes on. Now this has been taken care by the RNN network. So what it does, it does a very simple technique. The technique is same age old technique. Now if we are having a some regular pattern, and if we are not finding that regular pattern in the certain time series or of a network traffic or in a logs, it is a sign of a you can say intrusion detection system. So we are using the brute force attempts. We are port scanning, malware communication, or command and control server combinations are there. So these are the type of an intrusion system. Still it is there in use, but only the method is changed. And now we are identifying the patterns. We are actually training the model of RNN. What is the set pattern we have followed, what patterns the people are using, the end user is using, machines are doing it. And now if we found something other than that pattern, it is a suspicious patterns, and it is going to be a, you can say, alarm that it is a IDS. Like IDS stands for intrusion detection system. So there can be number of methods like brute force, we know, port scanning, like somebody is actually into the port scanning, malware communications with the command control. So these are the IDS. Now the third point that we go for a malware detection. So okay, this is a very,
Sir, Vaibhav
yeah,
sir,
please.
these slides are not moving. Only the first slide is shown displayed.
So just give me again a minute. Let me again share. Okay, now it's, you just tell me, Pankaj sir, it is moving now.
Yes, sir, now it is moving.
Yeah, okay. So what I covered, okay, let me again go through with it. So I have covered like what would be the outline. So outline would be sequence modeling, RNN, anomaly detection, user behavior analytics, predictive threat, log files analysis, phishing and fraud, automated incident response, challenges, RNN foundation and essentials, RNN practice and applications. So we started with the RNN, and I'm very sorry that slides weren't are not able. You are not able to view the slides. So this is the RNN. So it makes, or you can say, it is designed in a such a manner that neural networks are, or they need to handle the sequential data. So when we say a sequential data, so the sequential data would be only effective when it is handled in a time series analysis. Means when a data is getting captured and doing the real time analysis in terms of the every slice of a time. So that is a time series analysis, and it is actually very important in context of a cyber security, like in terms of detecting and predicting the threats. Like because in every, you can say, certain time frame, there may be some time kind of intrusion, some kind of a threat, some kind of a fraud has been happening on cyber security. Data breach would be there. So it relates to the data security part. And the what factors it all behaves, that we what factors we used to take care, it depends on behavior of a user, data traffic and the logs. So we talked about network traffic analysis. So what the network traffic analysis is to do, so we are actually analyzing the entire data over a spread over a time series data, like a time series data particularly over a network traffic, which actually identifying what are the unusual patterns. Now when we say unusual patterns, because when we are into the network traffic, we have a understanding, or you can say system have understanding what usual patterns we have followed. So I have given the example. Let's say a user is traversing some point in over a network where he has to move from point A to point B and then to point C and then C to come A. So this is the path they used to follow. Now, but somehow we are able to identify the pattern. The user is not accessing point B to C, it is directly going from point A to C. So it is an unusual pattern for the defined system that it is there. It's an unusual behavior. So anomaly can be there, and it can be like it can be the network intrusion. It can be the, like when we say DOS. So okay. So when we say denial of service, so it means that some kind of a bug is there, or some kind of an intrusion has been done, or some malware has been done, which is actually stopping us from going from point A to point B. But if we know the external path, and we are going back to the C. So this can be the DOS attack, or it can be the data filtration attempts. So we have talked about intrusion detection system. So this is again this is actually based on, you can say, by training the RNN model. So when we say RNN model, so we have an RNN model particularly applied onto certain system which has a sequence of network, or you can say sequence of logs, which is actually identifying the suspicious patterns. So where other we have a something called a you can say malware or something like that. But now what we are doing, we are just identifying the pattern, like number of users, what the users pattern for a data or for a connectivity or for a some service are there over the time. Now if we are seeing the similar pattern which we have given learning to the model, it is saying okay. If some unusual pattern is there, so the system will automatically inform it is an suspicious pattern, or it is an attack. Attack can be of a brute force login method. It can be the port scanning. It can be the malware. So it is all comes under the IDS systems. Then we have a malware detection. So here we are earlier. So now RNA is used to detect the malware. So when we say a malware, it means that some malicious activities are happening somewhere down the line, and due to some malicious activities, the file access paths are can be changed, the pattern can be changed, the network connection settings can be changed, the sequence of calls that used to happen again onto the systems are getting changed. So this RNN will, again, it would be a trained model only, and it will detect the malware detection from this, from which activity it is getting this kind of a pattern. Like if we are running some application onto the network, and I'm getting some abstract values from this on system log, so I can understand okay, by running certain value or by the hidden layer, I'm getting something value, it may be the malware detection. Now second point comes in terms of the user behavior. So now user behavior is, again, it's a correlation with the anomaly detection only, but little different. So we have a RNN that is actually learning now in terms of the user behavior. We have to give the understanding of a model for a exactly individual user or a group of users within organization. Okay, so let's say we have a group of teachers here. Some are professors, some are associate professors, some are assistant professors. Your organization has given certain roles and responsibility of a system access to the assistant professors. Now if we want to go level one up, they have the system which allows associate professors certain kind of applications, and the professors have a certain furthermore applications below the registrar, but they have certain more applications. Now if we have trained our model that assistant professors should view or can work from model A to model B, and after the model B, it should automatically goes to model C to the associate professor. If now some, but due to some any kind of intrusion or any kind of a problem, if behavior is anomaly, like if we are not getting into the system B, but we are getting into system C, or we are not passing it, we are not able to pass the value from B to C, it can be the user anomaly detection where we can use, it can be the access method problem, it can be the access frequency problem, it can be the deviation from the pattern, or some unusual access or sensitive files have been unauthorizedly attempts to be done. So it raises the flag, it raises the threat, it is a problem, or the account has been compromised. So this kind of a method is actually used in our social networks, where our Facebook or emails used to tell us somebody try to log in your machine from somewhere location, kindly change your password. So this kind of a method is used with this kind of a media. So going another slide for this one, user behavior analytics. So credential stuffing and phishing detection. So this is what I'm just talking about it. So when we have an RNN and it detects very unusual login sequence. Okay, now let's take a very basic example of an email login. Now we all have either Hotmail email accounts or Gmail email accounts. If we are using our email accounts on a certain machines, so machines used to recognize our pattern, our browser, machine addresses, MAC addresses, and now if you try to log in your email from some else machine, a new machine, I would say, it will use to ask you, are you sure it's your machine? Enter your authorization passwords. So this kind of a credential stuffing and phishing detection is based on the RNN, and which indicates that who is the user. If we are unauthorized to do it login by 3 times or 2 times, it suddenly raises us the email, or by some method somebody try to access our account. So this is the example of a user behavior analytics to the RNN network model. But again, we need to give this knowledge or learning to the model based on the individual user. The third point is the predictive threat intelligence. Okay, so before we talk on to the this attack, predictive attack, let's see, whenever we are using a password onto a real-time data sites or real-time sites, any of your accounts, it says that you require to be have some data having special sign, some number, some small alphabet, some large case of alphabets. The data length should be, a password should be 8 characters or 12 characters, something like that. So how we are able to design this kind of a fields? Now, when we say, if you have gone through the internet, you must have seen there would be the report published by the lot of uh, sites which says the how many passwords have been compromised, what the usual passwords people used to put in 2023, 2024. So on those patterns, the companies used to design a certain policy which says you need to change your password 30 days, 45 days, or the password should have this much of the length, this much of the criteria of a password. Why it is been done? Because it is the attack prediction. So by analyzing the series of a data that has been done in cyber attacks, the RNN models are trained to predict future of a threat. So if we see sometimes it says password is medium, password is very strong, low. So this is how this we used to have a predictive threat intelligence onto the machines right now, which we are getting it learned from the past experience, or if you can say past experience, and which follows the pattern, like what pattern the system flows, how it is actually compromising with the system, and we need to overcome with those things. So this is what we used to do. So we used to analyze the patterns based on the network traffic, allowing the security teams to take a preventive action. So this is what is the threat intelligence here. Any questions so far from anyone? Anything which requires more attention? I hope so. No. So now let's move to the another part of a predictive intelligence, that is the ransomware detection. Okay. So can I know like when we say a ransomware detection, what it is like? What we mean to say that ransomware? Can somebody inform me? So when we say a ransomware detection, So we have a certain, you can say, a bug into the software, a bug into this system. We don't know what kind of a bug it is there. It can be something related to the software, it can be related to the virus, it can be ransomware, it can be malware. So it all comes under the virus now, right, these days. So when we are actually having the RNN, which predicts the potential execution of a ransomware. So ransomware is a particularly file which attach insult to the file, and it makes the data unrelated to the behavior. So now we have an RNN model which actually are related and able to get the file access pattern. Now, if we are not getting that file access pattern or sequences, it probably the problem with somewhere down the line with the files or something which goes wrong with our data files right now. So in that sequence, if they detect, the RNN will raise a flag and it says it's a potential threat, but it will not stop you from doing the execution, but it will always give you the threat. It is a threat. So we have another topic, and that is the detection of an IoT network, like malware detection in the IoT networks. So, like IoT devices, like we have, like in our homes, we have electronic devices. Mostly now it is connected to the IoT only, like TVs are there. So now we have a entire time series of a data. Now, if you have ever wondered, you have watched some movie on Netflix or Disney or Hotstar, it says based on your choice, the following movies are there. Like if you have viewed Chronicles of Narnia, it will say, okay, it has part one, part two, part three. If you have Harry Potter, it can give you the line of the Harry Potter, like it is what is there. So it is actually what it is doing, it is actually generating a time series. Now, when we have an RNN network, which says, okay, this is the normal behavior of a user who used to view the so many movies or so many kind of data. Now we are getting some unusual behavior, like some applications are running in a background, some are running in a front end. So it gives the rn it gives the malicious activity detection to the IoT devices. Certain, look, the basic example for this one is the sudden search in the traffic or very unusual command sequences, like 2 3 commands going at a time. uh, might we have seen somewhere, like if you have it in your TV installed, Alexa or okay Google. So multiple commands used to take, you open a single command, it used to open multiple windows. It's a sign that device have been compromised, or the device is not able to open a certain type of a the network. This is due to the compromised device or a network bottleneck. So now let's come to the log file analysis. So this is one of the methods that we used to do it in our IT companies. So it is one of the methods. So we train the RNN to understand the logs. So when we say we train the RNN network to understand the logs, so logs are understand on the basis of their implementation. Either it is on server logs give the access details, whom access, what used to access for the servers. Firewall gives, okay, what rights, permissions, what kind of data is being scrolled, not to be scrolled. And then we have a Trojan detection system, which actually do the identification of unusual patterns, or you can say abnormal patterns in the log sequences. So when we do a programming, or when we do a building an application, we used to detect any kind of a error by logs only, because logs only tells us what is went wrong into the hidden state. So from this security log monitoring, we used to do the same part. So now there can be various methods that we detect in types of attacks, like SQL injections. Now you have a SQL statement running, and it is unsecured SQL server, so we can inject an SQL. We can have a cross-site scripting, that is XSS these days, which is very common. And we can have a 0-day vulnerability. We can exploit a 0-day vulnerability. So the 0-day vulnerability says when we have tested a system and we don't find any errors, but suddenly we occur and into the error, which is not related to a certain type of users, but it is an error due to the some unwanted activity by a user. This is known as a 0-day vulnerability. Then when we have an automated threat response, so when we have an RNN systems, we can train our RNN model, or we can train our RNN systems to respond automatically to the attack. So the best example is that if you have login, like if you have a one machine login to the certain set of data, and it is only run to be in India, and if we are logging that system from USA, it is automatically get logged out from India as well as from US. This is the method which is known as the automated response attack system. So when another type of one we have, that is an email phishing and detection. So again, so the core of our RNN is that we need to learn, we need to train that RNN model. So the email phishing technique, so train on the sequence of email communication and the metadata. Okay. Now here a new term comes. I hope you everybody knows what is the metadata. So we have now model based on the sequence of communication, email communication. So when we say sequence of email communication, you have seen that these days we used to receive a very stringent mail from very unusual IDs that can be non-existent IDs but virtually created IDs. So that is where the metadata comes into the picture. It identifies it is a spam mail or it is a non-spam mail depending upon the domain name, the content of a mail, subject heading line of the mail, the ID of that mail, and it detects the pattern like from which source it is generated and how the sender is able to send a mail with the timing and content. These all things are actually based to give us the phishing mails detection method. So when we have on this phishing mail detection method, so a same method is used to follow with the financial fraud detection method. So what we have to do in financial fraud, it actually traces the starting point of a transaction to the end point where it gets all the points of the fraudulent transaction. When we say fraudulent transaction, it says like a system is generated a response for a transaction from a point A, but instead of going to point B, it has gone to point first C, then D, then E, then it comes back to a B. So somewhere down the line, something is gone wrong, and that is why the financial systems have been traced out. Now, when we say automated response system, so when we have this kind of a sequence where it triggers or it finds itself unusual events or unusual patterns, it automatically blocks the IPs. Like if you do the bulk emailing, the IPs would be blocked. If you do bulk transactions, the accounts are suspended by the banks. So these are the automatic transition systems that is in place with the RNN model with the help of neural networks. Now here we have another that is now why we use RNN for a malware detection. So when we have an cyber security or a cyber attack, and we are often having the pattern like we need to identify what is the problem is going on. So we have a first pattern that we use to analyze, that is a sequential pattern for the malware. So what did we used to do? So we used to analyze the recognize, or you can analyze the patterns and the dependencies in time series data. Okay, so now what is the time series dependency data? For an example, we are having a, a login system which says me that I need to enter my username password, and after that I need to enter the some kind of a OTP or authorization code. Now after certain seconds, if it is not getting, it is actually denying me the entry. So this is what is called the time series data pattern, that it is if it is not getting, it is denying me. The second part comes in this is the dynamic adaptability. So when we say dynamic adaptability, RNN is trained in a manner that it actually learning and evolving the data itself and enabling to the new and previous attacks. Okay, so what we mean to say that here right now, we have a dynamic network which has the dynamic ability to learn itself on a dynamic data. So what is used to do, he will learn from the time series or from the pattern that had been done earlier, what can be the further attacks to it or further can be done. So based on his previous knowledge, it automatically analyze the past attacks, comes to the point, okay, this can be the third one, or it can be act in this manner, it can be stopped in certain manner where we can have an attack strategy. And this kind of a system, the adaptability kind of a systems are the most you can say the favored system these days, which have a robust kind of approach against the emerging threat. So it can immediately tell us, okay, the earlier system is, so these all systems are time dependent and time series method, that it quickly comes to the point that we have an attack or we can have a attack kind of a system. Now we have another system which is real time processing. So RNN. So once again, so when we have a model which is actually working on the processing of a streaming data. So when we say a streaming data, I mean to say that our data is getting streamed over a certain channel, and on continuously streaming of a data, we are getting data sets starting with the bit parity wise, like we have data from since 48 bits or 32-bit sequence, and it is getting it is getting it the process real time, and if he gets something else from that bit, it will automatically says there is some misconception to the data. So what problems or what challenges we still face? So RNA is heavily dependent upon the data, and when we have a noise in the data or we have a biased data and we have a incomplete data, that problems, it creates a problem, or you can say challenges for the RNA network. Another challenge that we follow or we base is the model complexity. So RNN itself is a very complex model, where we have to deal with the gated current units and the long short term memory units. So when we have this kind of a model which we have LSTM and GRU, so it makes it very complex. And when we are dealing with these large volumes of a time series, it creates a problem. It creates, you can say, not a problem basically, but it's a very complex system to get into the learning method or into the application method. Now what to be done, like, so for in terms of the challenges to be done, now cyber security people or the companies, they need to understand the model flat on a particular activity. So RNN is nothing but it is a deep learning model these days, uh, which can be difficult to interpret by the intruders, by hindrance, and by the insights. But we can have people who can actually flung to the system with the trace of RNN again. So it's a challenge for the RNN. So now let's start with the some understanding why the sequential model is used for RNN, how the time series is based on sequential modeling. So sequential modeling, so it's a basic first step towards creating an RNN model. So sequential modeling is a basically a concept in a machine learning with the data science, which deals with the data has an inherent temporal or ordered structured data. So I have given one example. Now, if you see the example here, I have put two example. Ram lives in Janakpuri, Delhi. Now another example says Ram lives in Janakpuri, Delhi, India. So what data sets we have here? We have a similar kind of a data set, but we have a data set different in terms of length and the nature. How it is different in nature, like you see. Now data set says Ram lives in Janakpuri, the first example. Second says Ram lives in Janakpuri, Delhi, India. So Ram, RN, we can train our RNN model that Ram is a person, lives can be some other identity, in can be other identity, Janakpuri can be the location, Delhi can be the location. Now, on the other set, we have a same data set, but having little different data, which says person lives other data set, in is other data set. Again, Janakpuri is a location, Delhi is a location, India is the location of a country. So what we have done, we are actually getting the sequential data in a manner that we can predict, okay, Ram is a person related to Janakpuri, related to India, related to Delhi. He may be living there or he may be working there. So this can be data. This is going for a feed forward example. So when we say a feed forward example, the example which says that data can be utilized into number of ways by putting data into different data sets and can feed us with the forward nature of a data is known as a feed forward. So this is what we used to do in a conventional method versus a RNN. So I have put RNN in my left and CNN in my right. So if you see in CNN, the outputs are self-dependent. We don't have any interdependency or dependency on outputs. But whereas in RNN, The input data is interdependent from the sequential pattern. Okay, how it is interdependent? If you see, go back and see, Ram lives in Janakpuri. So we have a some person, some identity. It has something, some other data set, which is I put like other in other, but Janakpuri is our location. But when you see now, if I break down this into the output of self-dependent, it says it means RAM is separate, lives is separate, in is separate, location is separate. So every data item is separate in that data set. That is the conventional method. In RNN, each and every data set is dependent upon another data set. So there is a correlation between in RNN between the previous input to the next input. So how it is done, like if you see, once again the same example I am repeating again. Now Ram lives in Janakpuri. It makes some second sense, it makes some sequence. Yes, it does. That is why there is a correlation between previous input to the next input. In case of a conventional, it don't remember the previous input. It is just like a recurrent network. Whatever it comes, it is a data set for him, not an entire data set or entire bit of a data or length of a data. That is why this is not a feed forward. This is the biased on your previous output. This is why this is a feed forward, because it is bias based on previous output, because we have a previous output, that is Ram is what, nothing. Ram lives in, so feed is the feed forward for each and every output. Now we have another stack that says memoryless models and the memory network models. So when we have memoryless models, so we have auto-regressive model. So okay, so this I have taken this source from the Siemens. Siemens has done the work on this model, and in 2017 you can find this model anywhere on net. So auto-aggressive model. So now what does it do? Okay, so we have an model which is auto-aggressive, which means the next input sequence is fixed number of previous inputs. So we have a weighted, so W is for weighted input. So we have an input which traits, and with WT we have an input with W. Okay, so what it says we have two inputs combined together into input T, which is our auto-aggressive. So we are having delay into the our inputs, but in final output would be the combined into our input. In the feed forward method, we have another, we are using the same auto regressive models only. So it's a non-linear. So it means we don't have any kind of a hidden layer. All the inputs are combined for forming into a single input. In form of a memory networks, it has a dynamic hidden state. Okay, so when we say a dynamic hidden state, it means there can be a distributed hidden state, there can be a non-linear hidden state, dynamic, it can be temporal or accumulative. So what difference we have? So when we have a distributed hidden state, it says that there can be a lot of information stored, but we need to found our information. Non-linear says we have an update information hidden state in a complicated manner. It's like we can have weighted mean, we can have every data information, we have particular information, we need to correlate them. And temporal means it is built on the semantics. Example, word by word sequence are there. So next comes to the essentials for the RNN. Now when we say essential, so like these are the three models, or you can say three techniques for models that we use for RNN. Number one is the model long-term dependencies, and second is the connect previous information to the present task, and third is model sequence of events with loops allowing information to be persistent. So let's start with the first model. So we have first model, like how the foundation of RNN will work. So first of all, it is very much clear that we should have a ability of any model to handle the data into the sequential part, or you can say we should able to handle the sequential data. So when we say a sequential data, it means like it should has a time series, or it's like speech, like I'm speaking. So every word I'm speaking it has a some millisecond gap, but it is still it is coming. So it is a every time series has something, and it has a natural processing language. So it has to be NLP. So now when we say which is crucial tasks such as time series, so now the speaking is the best example. Like I'm speaking, every millisecond have some other word. The words are getting correlated, they are interdependent, we are able to understand or we are not able to understand, but still it is there that we can say yes, it is a RNN kind of a model. When we say a sequential data, so when we say a sequential data, the now RNN are designed to work with the data that has a sequential structure. So okay, so when we say a sequential structure, so it means the output depends not only the input but the previous input. Okay, so let's say we all are here for the understanding of a RNN. So we have some previous input about okay, this is kind of a development program. This the current input would be the RNN, and the current output depends upon whether I am able to understand or not understand on the previous input on the current input. Previous input was FDP, current input was RNN. We can combine together. So the example is the language modeling. So here comes the second path, the recurrent connection. So when we say a recurrent connection, here comes the part of a neural network that neurons. So we have a straight connection like we have in neurons in our body. So recurrent connection means sending information back to the itself and processing an output. So same we used to do in our brain. Body used to do same thing. So this allows the feedback loop. So when we say a feedback loop, it means it remembers the information from the previous step, or you can say previous time step. It remembers the information. So mathematically a time step is known as T, and RNN takes an input like TXT, updates it in the hidden state that is HT, and generates output as a YT. So it as follows. So this is again taken from a Siemens source for 2017. So we have an HT, like this is the mathematical formulation for this one. HT equals to function that is W. W is your weighted matrix, or you can say based on bias terms. And we have an output Y, which is again, that is the our output. It comes like weighted matrix with the hidden state data by the basis bias terms. So the important point in this entire equation is this, that we can have a input with the number of weighted biased terms. It can be single, it can be multiple, it can be n number of things. So now when we say RNN computational graphs, so like same what we have in database, like one to one, one to many, many to one, many to many, and many to many again. So like if you see O stands, the green one in O stands for output, X stands for input. So we can have we can have number of inputs correlate to one output. We can have number of outputs correlate to number of outputs. We can have many to one, many inputs are there, but we have single output. And same, we have two, many to many, like two cases we have taken. Two inputs can be two outputs. Number of inputs can be number of outputs. So these are the mathematical computation relations where every hidden state of a data is corresponds to the previous state, and it produces the current state for the output.
Neither third person. Wow. Neither third person.
Yeah, say somebody saying something. Okay. So another we have an back propagation through the time, that is. Pankaj, can you mute someone, please?
Participants, keep your mic mute. Please keep your mic mutes, participants.
No.
Okay, so we have another fundamental, that is foundation for this one, that is a back propagation through the time, that is BPPT. So when we say a BPPT, so basically it's an algorithm which says that model is trained by the variant of a back propagation. When we say, it means it unrolls the time and calculates the gradient of each step. Now, please, this is all theory. This is, if you see the this diagram, we have a time instance starting from zero. Now, this time instance is having the parameter, that is the weighted hidden layer and the output for a W. So, in a particular time instance of a first time instance of zero, the weighted W can be weighted to W3. W3 can move up to W4. W4 can move to W3. What it means to say that? It means to say that every step on a back propagation is actually calculates the gradient. So when we say a gradient, it means nothing but the hidden parameter or hidden layer with the output that the system is able to understand, remember for the next time execution model. It creates a pattern for that one, which is a recurrent connection and which accounts for the dependencies across the time steps. So this is what is the exact time series analysis has been doing there here. Because a certain time, 0, W1, W2, W3, W4, they all are getting into the next output level, which is used input by the W1. So it is a connection, recurrent connection, which has a hidden layer, which has an output, and moving forward with the next time series. So now we have here in RNN in practical. So I wanted everybody should understand like how the RNN model has been applied in the IT world these days, how we are taking the example for it. So for the first example for RNN, that is the NPL, that we used to do the NPL as a text generation. So when we say text generation, the GPT model is there. You can just type what you want to write. It will give you the entire writing flow. AI assistants are there. Machine translation, Google translations are there. We can do it like from Hindi to English, English to Chinese, Chinese to Japanese. Everyone is using these days the translation part. Then we have a semantic analytics. So this is basically the social media reviews that machine used to give you. It used to say, okay, you have an organic flow, you have an inorganic flow, you have like customer reviews are coming. Now these days, if you see the semantic analysis, if you put something for a X company, this somebody from company responds you back, okay, we have requested your problem, we will do this, we will that. That is a part of semantic analysis. Then we have a named entity relation correlation. So this is basically a method that we used to do for an entity model. So when we say entity model, like every entity is having the, you can say, some particular IDs that is attached to these networks where the semantics will work. So C and D are correlation, works with the correlation. The speech part, when we say a speech part do we can use, like I'm using it, so we can also use same, like we can develop our model, that is Siri. We can have a Google Assistant, Alexa. In fact, not even this one, like speech part. If you have a smart TVs in your homes, you used to have a remote which used to take a Google Assistant or something like that, and it takes your next command and do the work. Like then we have a time series forecasting. So the RNN is basically used in these all these methods these days in practice. So in time series we have like weather prediction, demand forecasting. Even time series prediction forecasting is done in terms of your stock markets these days, because we can predict the market very well. Next we have like we can
Participants, please keep your mic mute.
So in terms of the RNN in practice, so audio, video, image sequences. So best example, that is YouTube. You upload a video to the YouTube. and it automatically asks you that you want captions. If you just click on yes, it automatically starts putting the captions. That is the audio video sequence it is creating by itself. Secondly, if you see the frame by frame analysis, okay, so when you have a some you can say software which is actually we are having frame analysis, we are cutting one frame and joining another frame to a certain frame from a large video file. It automatically starts doing it. It is a frame by frame analysis. In fact, if you see this analysis is done by WhatsApp. When you upload some video on your status, takes the frames. It says, okay, this much frames for 30 seconds can be uploaded to the WhatsApp. So that is the frame video analysis part. Then we have a healthcare. So the best example for time series is ECG modeling. Like anybody having a heart trouble, doctor used to take measure the graph. Where it dips, it's a problem. If it is not dipping, it is going straight in line. It is a time series data. It says the heart is working perfectly fine. Or in terms of like ECG, you have EEG also, that is also used for the healthcare patient monitoring. You have monitors onto the screens where doctors see the graphs and say, okay, everything is fine or it is not fine, just because of this practice. Reinforcement learning. So best example is robotics and control systems. So control systems, when we say that we have a control system like boom barrier systems, fire exhaust control systems, so these are the control systems that is reinforced learnings. It takes certain commands, start doing it, no command not start doing anything. Anomaly into the detection. So that is another area of fraud detection and network security, which is taken care by mostly by the financial companies, data companies these days. And the fifth one is the uh, autonomous vehicles. That is a that we have like planning paths. So the Google Maps or the maps are the best example for it. The trajectory planning is the example for the self-driving cars. So this is what we have. So now in terms of a conclusion, so whatever models we have learned here or we are seeing in terms of a practice, they cannot be done without the long short term memory, that is LSTM. So when we say LSTM networks and the gated network, they are a powerful tool for analyzing the time series in a cybersecurity. So everything that we are doing in right now, either we are having cybersecurity, either it is YouTube, Gmail, emails, bank accounts, everything we are using cybersecurity, and it is we are able to achieve some kind of a you can say perseverance over the threats or security is there just because of the RNN, and RNN uses the LSTM and the GRU. So by learning from the earlier sequence of patterns in the network logs and the behavior, RNN plays a role in detection in terms of the threats, attacks, and responses. It automatically responds to that attacks, whatever he has learned. In case he has not learned the attack, what he needs to respond, it cannot respond back to the that attack. But most of the times, the networks are very intelligent these days, and the continuous learning model with the now is going on, which are actually creating AI also into this by the RNN right now, which is able to respond to the network. So what challenges we have? So we discussed earlier also, we have a challenges related to the data. So now when we say noise in a data or data quality is not good, which creates a problem for that. So the lot of work needs to be done on the data quality model part and the explainability to address the fully potential of a RNN network. So data quality is something which is there, which needs to be worked upon. And I hope I have given the entire learning resources for the people that if they want to learn more about the RNN topic about the RNN. So these are the certain reference. It is there. I will share the slides with the entire audience. Entire audience can go through it. If they found it valuable, you can go to the further learning resources. So these are the resources that I have put somewhere. So it starts with Coursera to network to Siemens, everything it is there. And thanks from my end. Anything, any question that I need to respond to someone, I'm happy to do it.
Thank you so much, Dr. Weber. So it was a wonderful session. The participants, you can drop the query, if any, in the chat box.
So I have received one question. What is the role of a federated learning play in training in RNN on time series distribution across the multiple? Okay, so when we say a federated learning, so it means that we are having the organization which have this spread into the number of segments. So when we say federated learning, so it is basically a machine learning which allows the multiple devices, like we can have multiple units having multiple devices, multiple systems which we can use into the RNN. Okay, now your question says on time series data distribution. So federated data into it shares the raw data. When we say raw data, like mm, it can be the metadata that is used by one department, and the same metadata can be used by second department with some kind of a more hidden layer. So now when you want to ensure that it should not be privacy, it should be secure with the security part. So we need to train our model in a manner that not the entire data metadata should be passed on, whatever is required. So we need to use here data exploration method here. So by doing the data explanation method, we can only give the filtration method what metadata to be used by the next organization or a multiple say into the multiple scenarios. So it can be used only for a particular method, not an entire set of data that we can do here. How RNN works in fog and edge computing. Okay, so like so it comes the Vijay Lakshmi it comes under the weather prediction method for a fog and edge computing for IoT devices. So for a fog, we have a set pattern. We have it follows the pattern of environment, density, measurement of light, everything. And when when we combine this series of data with the IoT devices, it automatically goes to that part where RNN works with the model which says, okay, the density, the light, the duration, the time frame, all these sequences are matched. There may be other sequences also which I may not right now knowing. It can match with those data, and it can predict, okay, this is the IoT device which can work, which cannot work. So I think Cat5 systems are the example for the RNN network only. So Nagarajan has put a question: how can RNN be combined with other learning machines, machine learning, such as clustering with the cyber security? So okay, so your question seems to be good. Hmm. So we need to have a response and detection system based on for this one, like Nagarajan. So for clustering and reinforcement learning, we need to give that learning, or you can say threat detection to the system based on the combined efforts of other machine learning techniques. What can or like a threat can be for me, it can be X, for you it can be Y. So we need to give the combined learning to the system, so it can comes over it and it can produce the threat detection. So when we say threat detection, it means it has to enhance its detection and response mechanism for the same. For this, we need to have a predictive and neutralized threat method to be there. Okay, you have another question. It says, how effective RNN in identifying slow, steady saver effect from time series log? Okay, so it's basically Nagarajan. It's a very effective system. When we say it has to identify only the pattern which have been breached. It if the pattern is not breached, okay. Let's say we have a one pattern. which is not learned by the system. System says it is a breach. Now after you analyze all the things and you say it's not a breach, we can give that learning to the RNN right now. Now we have a model which is learning something new, which is not is incorporated in which. So we are now giving this kind of a knowledge to the system, so that is where these threats will eventually go off from the system, and system will start learning itself to the more advanced stage. So we have another question. I think we I am good about your question, Nagaraja Lakshmi, Vijay Lakshmi. I'm going to taking a third question. Which algorithm is good for image processing? Image. So, madam, you do the image processing in which manner? I want to understand that first. If you can explain me a little bit. If you use Gaussian method is the one of the I consider most good in enough in terms of the image processing, because it contains the smallest of the articles, and it uses a denoise image also. And after that is a TensorFlow that Microsoft has developed. The TensorFlow is very good in terms of this in terms of this. So you can use both of them from as per my understanding. So we have another question. Your question is unclear, madam. Watermarking. I'm sorry if you can explain it little bit. So I have one more question. How does the vanishing gradient problem affect the performance of RNN series, and how can it be mitigated? How does the vanishing of a gradient problem? So our gradient problem is used to happen when we have a problem of the uh, uh, GRU, when we don't have the GRU and LSTM into the network. So the best part to overcome with that, we need to break every weighted data into the smallest of the unit. Like uh, just break the unit into W1, W2, W3, W4. Then you have a multiple W's dependent upon multiple W's output. Then the previous output becomes the input for the other another one. That is only the method that we can do. We need to break that like smallest part to the smallest part. Uh, Sondravali ma'am, I'm not able to understand your question. Watermarking, what is that? Please, if you can suggest me. Thanks, Nagarajan. Okay, so you are asking what deep learning algorithm good for watermarking task. So you make a watermarking. I think you should go for the another time. I think you should go for convolutional neural networks, or the best algorithm for is used would be the extract water from images, like embedded and extract. You can use embedded and extract. That can be a good algorithm for you for this one. The best you can do for this algorithm would be the deep learning method. You can use the extract. You can use MLP, that is known as multi-layer perception pattern systems. Okay, I have another question. In user behavior analytics, how can RNN help in identifying anomalies from insider threats? Okay. So, sir, insider threats also have some kind of a pattern or sequence, which is not related to the we have not given to the RNN. We need to learn them. That is only the method, that every time series method, every time series data probability we need to give to the machine. We need to give the learning to the model. That is only the method. I think I have answered most of the questions to the
Yes,
satisfaction
sir.
level. If not, I'm very sorry
Thank
for
you,
that.
Vaibhav sir, so much. And the queries are appropriately resolved. And it was a wonderful talk. And on the behalf of organizing team and all participants, I take immense pleasure in expressing my heartfelt gratitude to Dr. Vaibhav Bansal for delivering an outstanding and highly informative session on recurrent neural network applications time series analysis in the cybersecurity. So, Dr. Bansal's ability to simplify the complex concepts and bridge the gap between theoretical frameworks and real world applications is truly commendable. The depth of knowledge and practical insights that the expert has shared have not only deepened the understanding but also opened new avenues to explore in the domain of cybersecurity and artificial intelligence. So, the discussion on leveraging a recurrent neural network for time series analysis in the context of cyber threats has sparked significant interest among the participants, inspiring them to think innovatively and adopt cutting edge approaches in their work. So I also want to thank this opportunity to thank all the participants for their active engagements and enthusiasm. So together, let's continue to learn, collaborate, and make meaningful contributions to this ever evolving discipline. So I am thankful to the resource person as well as the participants for sparing the time for attending and sharing this informative session. So thank you everyone, and thank you Vaibhav sir for the
Thank you,
wonderful talk.
Pankaj sir. Thank you all participants for giving me a chance so I can showcase what I know, what I have understanding in terms of the RNN. So just for an update, I have done this work on networks way back in 2009, 2013. I am doing this one. Now I'm currently using this one in our project. So thanks everyone for giving me this opportunity. Thank you, Pankaj ji, and thank you everyone to the organizing team and the participants. Thanks very much. Thank you.
Thank you. Thank you. So dear participants, the attendance is already uploaded on the Atal web portal. So the last 3 days attendance is already shared in the WhatsApp group as well, and on the Atal portal it is already uploaded. So again, you are requested to be to participate and attend all the forthcoming sessions regularly. And the resources being shared by the concerned experts are already uploaded in the document section of the Atal portal. So you can utilize those resources to enhance the further knowledge and skill set, and to prepare for the quiz to be executed executed on the last day of this 6 difficulty development program, that's on Saturday. So this session is open for further 5-10 minutes. So if anyone has any query or doubt or any conversation he want to have, so he can unmute himself herself or otherwise drop the query in the chat box.